Chapter 10 is areas of plane figures. Section 1 is pre-chapter 10, skills and practice. We're going to take a look at how we come up with area formulas so we can understand where the formulas come from. And then we're going to look at converting between one unit and another. We're going to have a lot of unit conversions in this chapter. Section 2 is areas of squares and rectangles. 3, parallelograms, triangles, and rhombuses. 4, trapezoids. 5, areas of regular polygons. 6, circumference and areas of circles. 7, arc lengths, and areas of sectors. And then we have the odd answers in the study guide. So we're going to do some pre-chapter skills and practice just to make sure we're ready for chapter 10. Now, the first part of this looks kind of crazy, and I'm not going to really try to explain all of it. Uh, but what I'm showing you is 1 dimension, 2 dimensions, and 3 dimensions. And I want to kind of give you the gist of what this is trying to say. So what I want to do is I'm going to pause for just a moment, pull up my Algebra 1 book on page 174, and show this to you here. The numbers I used here are a little crazy because I actually drew it to scale and it gets a little weird to try to figure this out. I do want you to be able to see, though, that length is 1 dimension. Area is 2 dimensions. And when we're talking about area, we're talking about little square blocks. And then volume is 3 dimensions, and so volume is these little cubes. So we were trying to give you a visual. Excuse me. That length is 1 dimension, area is 2 dimensions, volume is 3 dimensions. When we convert, we have to think about the number of dimensions. Notice that if we measured in centimeters, the length in centimeters, we'd have centimeters to the first power. Area is 2 dimensions, length and width, and so we end up with centimeters square or square centimeters. When we had volume, we have length, width, and height, 3 dimensions, and so we measure volume in cubic units. Because of that, we reach this conclusion, which is really what we're trying to get to. Length is 1 dimension, so when we convert, we use the conversion factor to the first power. Area is 2 dimensions, so when we convert, we use the conversion factor to the second power. Volume is 3 dimensions, so we would use the conversion factor to the third power. When you go from larger to smaller, you multiply, or smaller to larger, you divide. But we prefer to use dimensional analysis. So, again, what I'm going to do is I'm going to go back to page 174A in my Algebra 1 textbook, and then I'm going to show you this from that page so you'll be familiar with the way we did it there. So I'm pausing and going there. Okay, here we go, page 174A of the Algebra 1 textbook. We said when you go from larger to smaller, you multiply, smaller to larger, you divide. But we're really going to use dimensional analysis, as you can see down here at the bottom. We're going to get to that in just a minute. Perimeter is 1 dimension. And so if we're going to convert, we're going to use the conversion factor to the first power. Area is length times width. It's 2 dimensions. And so we use our conversion factor squared. Volume is 3 dimensions, length, width, and height. And so we use the conversion factor cubed. And then we have what we call the drill. We said if the dimensions of a figure are increased by a factor of x, then the perimeter, which is still 1 dimension, is increased by that same factor x. The area, which is 2 dimensions, would be increased by that factor square. And the volume, which is 3 dimensions, would be increased by that factor cubed. Okay? So here's some examples. And we're going to look at the dimensional analysis approach. So let me get rid of that and let's do this with dimensional analysis so we can see what we're talking about here. I'm just going to get rid of the whole bottom. Whoa, shoot low. Okay, now here's how we use dimensional analysis. We take what we start with and we multiply by the scale. And so we said, okay, we're starting with 3 feet. And we're going to multiply by whatever scale factor it takes so that we lose the name feet and gain the name inches. We're trying to go from feet to inches. And so then we think about our conversion. 1 foot is 12 inches. And then we want to think about the dimensions. We're talking about feet to the first, inches to the first. So we're going to have 12 to the first, 1 to the first, which is 12 and 1. And so then you would have lose the name feet, gain the name inches. 3 times 12 is 36 inches. Now, when we go from square feet to square inches, we're still going to take our start times our scale. We started with 3 square feet, and we want to change into square inches. So we started with square feet, and we're going to multiply such that we lose the name square feet and gain the name square inches. So then we find our conversion. 1 foot is 12 inches. But we're not dealing with inches and feet. We're dealing with square inches and square feet. So we square our conversions. And so what we're going to have is 1 and 144. 12 squared is 144. So area is 2 dimensions. So we use our conversion factor squared. The name square feet cancels the name square feet. And then we multiply. 3 times 144 is 3, 4, 20, and 12 is 432. Like to lost that. 432 square inches. Okay? So in square units area, we had to square our conversion. Okay? Number 9 there, we're beginning with 3 cubic feet. We want to lose the name cubic feet and gain the name cubic inches. We're dealing with volume here. So we use our conversion. 1 foot is 12 inches. We're not dealing with feet and inches. We're dealing with cubic inches and cubic feet. So we have to cube our conversion. 1 cubed is 1. 12 cubed is 12 times 12 times 12, which is 1,728. So we lost the name cubic feet, gained the name cubic inches. 3 times 1,728 is 3, 5, 10, 5, 70, 580. Ooh, I lost it. 3, 5, 5184. Let me do it again. 3,000, 2,100, 5,100, 5,184. Good. Cubic inches. All right. Any questions on the converting? So we got to know that as we begin chapter 10. All right, let's go back to the chapter 10. We just took a little peek at page 174A of the Algebra 1 book. We're going to go back to the geometry book, chapter 10. Okay. Now, we will consider we've sufficiently covered that part as we went back to the algebra book. So let's take a look at some examples here. We also need to understand the metric system. We also need to have these basic units memorized. 1 foot is 12 inches, 1 yard is 3 feet, 1 mile is 1,760 yards. You will be able to use a formulas chart, but you need to have some of these memorized. The basic unit on metric, the ones place for length is meter, for volume is liter, and for weight is gram. A meter is about 39 inches, a little over a yardstick, about the distance from the floor to the doorknobs. A liter, you know what a 2 liter bottle looks like, so a liter is about a quart. A gram's about a paper clip, a small paper clip in weight. Deca is 10 of something, hecto is 100 of something, kilo is 1,000. Deci is a tenth of something, centi is 100th of something, and milli is 1,000th of something. So you need to understand those metric prefixes. As you go back and forth, it takes 10. 10 centi make a deci. 2 moves is 100 because it's 2 jumps of 10, and 10 times 10 is 100, so there would be 100 milli in a deci. So as you move across the metric system there, 10 of the one makes the other, but if you make 2 jumps, it's 10 times 10, which is 100. 3 jumps, 10 times 10 times 10, which is 1,000. So that's how you use your metric conversions. Okay? So memorize the basic inches, feet, yards, miles, and memorize your basic metric prefixes. Okay? All right. Examples. Number one. Number one, we've got 84 square inches. We're going to do these from a dimensional analysis approach. We're going to multiply such that we lose the name we have and gain the name we want. So we want to lose the name square inches and gain the name square feet. So we say, well, 1 foot is 12 inches, but we're not dealing with feet in inches. We're dealing with square feet and square inches, so we have to square those conversions. 1 squared is 1, 12 squared is 144. And so what we have is we lost the name square inches, we gained the name square feet. We have 8 over 144. Now, we can reduce that by dividing by the greatest common factor. If we divide by 2, we would get a 4 and a 72. We divide by 2 again, and we would get a 2 over 36. We divide by 2 again, and we would get a 1 over 18, which means we could have divided by 8 to start with. And so we get 1/18 of a square foot. 1/18 of a square foot. Okay? Don't be afraid of getting fractions in this textbook. In fact, it's almost scary if you get a whole number in this one. So we don't want you to be scared of those. All right. On number 2, we have 1,200 cubic centimeters. We want to lose the name cubic centimeters and gain the name cubic decameters. Which one is bigger? Deca. So that's the big one. So one of those is how many of the little ones? Well, how many jumps is it? Well, it's 1, 2, 3 jumps. Every jump is a times 10. 3 times 10s is a times 1,000. So 1 deca is 1,000 centa. Well, we're not dealing with deca and centa. We're dealing with cubic deca and cubic centi, so we have to cube the conversion. Now, when we cube those, 1 cubed is 1, and 1,000 cubed is a 1 with 3 zeros 3 times. See, cubed would give us those 3 zeros 3 times. So we have thousands, millions, billions. So there's 1 billion cubic centimeters in a cubic decameter. So we lost the name cubic centi and we gained the name cubic deca. Now what we have to do is take that 1200 and we're going to divide it by 1 billion, which would move the decimal 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we would have 0.0000012 cubic deca. In scientific notation, that would be 1.2 times 10 to the, we have to put a 6. We made our number too big. My exponent has to make it little, so we put a negative to show we want the reciprocal of 10 to the 6th, which would be 1 over 10 to the 6th, which would make it 10 times smaller, 6 times over. Okay? So here's the answer in standard notation. Here's the answer in scientific notation to number 2. Any questions on that? Okay? You can play with some more of those conversions. Let's just look at number 13. We got some squares down here. Oh, let's just do 17 through 20. It's a little bit harder, so we'll do that one. Now, we know that a square has 4 equal sides and 4 right angles, so the angle at 3 is 90, so angle 3 is 90 degrees. We also know that when you draw a diagonal in a square, each diagonal bisects a pair of opposite angles because a square is a rhombus, and that's a property of a rhombus. When you bisect a 90-degree angle, you get a 45, 45, 90 triangle. So we got a 45, 45, 90 triangle. If we use the formulas for 45, 45, 90, in a 45, 45, 90 right triangle, the legs are equal, and the length of the hypotenuse is equal to the length of a leg times the square root of 2. Now, what we know is the hypotenuse, and we're looking for a leg, so we're going to have hypotenuse 6 equal leg x times the square root of 2. We want to solve for x, so we're going to undo multiplication by division. And so we have x is equal to 6 divided square root 2. But we can't have a radical in the denominator, so we're going to rationalize the denominator by multiplying by square root 2. And so we're going to get 6 square root 2 over 2. Remember, on the bottom, what we've done is created a pair of 2's, and from the pair of 2's, out pops a 2. The 6 and 2 will now reduce, and so we get 3 square root 2 for x. Any questions on that? Okay. Now, the next part is a little weird here. Page 253, it's sideways, so I could get it all in there. What we're doing is we're discovering the formula for the area of a square, rectangle, parallelogram, rhombus, trapezoid. So I need everybody just to kind of lay down on the floor and look at this so you can actually see it straight. No, I'm just kidding. Uh, so if you look in your textbook, you can follow this a little bit better. I'm not going to try to go through this sideways because that would be just a little weird, but I'm going to explain it. So I'm just going to draw pictures and explain this to you. So I'm going to come up with a blank screen here and just kind of lead you through this, okay? I do want you to see when we're dealing with area, we're dealing with square units. So we've tried to create for you the concept of square units when you're dealing with area, and hopefully you're going to tap into that quickly. But then we want to talk about why the formula for this is a square is what it is, why for a rhombus it is what it is, and all that kind of stuff, okay? What I'm going to do is just let what I've recorded so far be part 1 of the pre-chapter 10, and then I'm going to copy and paste this in my smartboard in a smart document and turn it sideways, and then we can actually go through it. So I'm going to go ahead and stop and then recreate this in a way that we can take a better look at this together. All right, so be looking for pre-chapter 10 skills and practice part 2.